Lots of apps need to guess what users want right away. Think about things like figuring out what ads to show somebody, noticing when somebody might stop using an app, or spotting trends in data to guess what they're going to do next. These are all real-world examples of what customers are doing in Bigtable today, and the demo I'm going to show you walks you through some of the features in Bigtable that are purposely designed to support these time series-based user intent use cases. Our demonstration will use fraud detection as an example. That's a use case where applications must rapidly respond and adapt to changes. We'll start by using BigQuery's data export function to bring in a list of known fraudulent merchants, and that's going to help us validate our transactions in real time. We can take advantage of Bigtable's conditional rights to validate our transactional rights against that list, and we can also use aggregations on right to update specialized counter data types, and that's going to help us track how many transactions and how many block transactions occurred in the last hour for each credit card. That way we'll have an easy variable to use to identify a high volume of transactions that might be indicating fraudulent activity. I'll then use the Agent Development Kit, which is Google's toolkit for working with AI agents, and offers built-in tools for working with both BigQuery and Bigtable. We'll use this agent to look at the real-time transactions in Bigtable and augment it with the cardholder information stored in BigQuery to help make fraudulent determinations and write that analysis back to Bigtable. Finally, I'll show how to create a continuous materialized view in Bigtable. This view will constantly track merchants with the most transactions within hourly time buckets. This view is going to serve as our base data for our fraud detection dashboard. This is also going to include agentic analysis as part of the dashboard, and that'll give security reviewers additional information to determine if merchants should be added to a real-time block list. This demo is all available in GitHub, so if there's any features you want to try, you should be able to go grab the code samples and have everything you need to get started. So with that, let's jump in. We're going to start out here in Bigtable Studio, and we're going to be looking at this transactions data set. I'll go ahead and write a SQL query so you can see what this looks like. Everything is keyed off of the single credit card number. This is a dummy credit card number, obviously. But what we come back with is the latest transaction, as you would expect in a regular SQL statement, just the latest values. But because this is Bigtable and we can store time series data, I can look at all of that data. If I just do a with history true, now rerun that, and we can come back and we can see that that credit card number actually has all of this, has a record for all of the different transactions that occurred on this credit card. We can make that a little bit easier to say, to use by using to look at by looking at this onPack function. Actually, the syntax is select. And I'll take a look at it now. And you can see this is just a more row-oriented format where all of the different transactions all are associated with the timestamp. And so let's say now I want to bring in some additional data. Let's say I want to import some data from BigQuery into this table. And this is going to give me a template that I can use. I can quickly fill out with my own query, but I'm going to bring in my own query to do this. And in this case, what I'm looking for are this is fraud is true, and maybe that got generated by some offline analytics where now I know I have some good data that says this data is likely a fraud, this merchant is likely fraud, and so if I run this query, I can run it directly from BigQuery into Bigtable. And what that's going to look like is once that query runs, what I'll come back and I'll be able to do is I'll also be able to look at this block list. And you can see I have all of these block list merchants that came back from BigQuery's analysis, so I can use these as a way to have a conditional filter to make sure that I'm going to block these known fraudulent merchants. So normally with Bigtable, you can support millions of writes per second around the world. And so you'll have data coming in from like a Kafka cluster or multiple different CDC feeds. But in this case, just I wanted to slow everything way down so you can see what's going on with Bigtable. And I just built a little Streamlit application so we can walk through how this works. So let's say here I've entered that credit card number we were looking at, and I'm going to give it a new transaction, and I'm going to give it this merchant how POC. And of course, this is Bigtable. I could add additional flexible data, and Bigtable can capture that no problem. But I'm just going to go ahead and submit this to Bigtable. And I'm showing a code sample here of exactly what's happening. And so what's happening here is I'm doing a row filter to check if that merchant is on that block list that we loaded from BigQuery. And we'll go ahead and check that. And yes, okay, that merchant did show up. They're on the block list. And so what's going to happen next is I've also incremented this counter to make sure that we're looking at complete the block transactions as well as completed transactions, and that might give us some indicators in real time that something's going on. And so that one failed as it should have. It didn't write to Bigtable. It recognized it as a potential fraud. But I can go ahead, maybe give it a different merchant here, and we're going to resubmit that. And that one, it went through as it should have. And so we've submitted that transaction. And now what I'm going to go do it is go right in that fraud detection agent on all the historical transactions along with that more recent transactions. And while that runs, I'm going to show you what's actually going on here. So this is a Bigtable fraud agent folder. Once you come in and initiate ADK, it's going to set up a lot of this for you. And the core logic here, the core driver is this agent file. So in this agent file, I have Bigtable tools that are directly integrated with ADK, as well as BigQuery tools that are directly integrated. And so what I've done is I've written this little tool for finding the Bigtable transactions. And all it really does is it pulls from a view that has the transactions data that we need by the credit card number. And then it'll execute that SQL, and all this, the magic of ADK here is that I don't have to worry about how to go and execute all these different calls. It all is just easy to run from ADK. And then the agent here, I've given it my Bigtable tool for finding the transactions, but I've also given it a BigQuery tool set, so it knows how to go and augment some additional cardholder information from BigQuery. And if you want to see the prompt about, what am I actually saying to the agent, what does it know how to do, this is in the prompt file. And then finally, what the code actually does from Streamlit is it makes a call into this agent analyzer. And essentially what this is doing is it's setting up an agent runner. It sets up this agent runner, and then it's sending it the text that I want and then returning a result. Let's hop back over to Streamlit, and you can see it pulled my data from Bigtable. I'll filter it by, okay, here's that Crooks and Sons, my most recent transaction. And it did detect, hey, there might be some fraud here. So even though it was not on the block list, it shows this is very suspicious, and that's based on, this card holder is this 20-year-old female student, and, it's not unusual. They do outweigh there's some fraud indications here. And it wrote that fraud analysis back to a Bigtable table. And so back in Bigtable, showing you a little bit more behind the scenes, this view transactions is a logical view. This is a standard view that you might expect in SQL. And all we're doing here is we're taking that flexible schema that we had for storing the transactions, and we're making it easier to consume with an agent. This all gets essentially run in real time as that agent calls it. But another thing that we're going to do is we're going to create a continuous materialized view. And I can see let me show you the definition first. And what we're doing with this continuous materialized view is we're going to time bucket by the hour all of the different merchants, and we're going to do an approximate count distinct. Now I'm doing that approximate count distinct based on the hyperlog algorithm. This is essentially generating sketches that can be merged, and this is really advantageous in these distributed systems where you might have different counts coming in from across the world, and they can all get merged correctly. And again, this is an approximate count, but it's going to show us within every hour, are there merchants that have an exorbitant amount of transactions which might be indicative of fraud. And so we're going to use this materialized view here as a basis for our dashboard that's looking at these transaction hotspots. And we can actually marry this data with that AI analysis that was done as these transactions were coming in. So here's that Crux and Sun I just entered, and I can see that, hey, the AI did pick this up as fraud, and so maybe in real time I want to go ahead and start to add this to our block list. So all that code that you just saw, it's all available. If you want to try any of these features, there should be samples in this GitHub repo, so feel free to come and give it a try. Thanks a lot for watching, and hope this is useful.